Hi, this is Ms. Pellegrin, and today we're going to be looking at Module 4, Lesson 13, Changing Scales. In our opening exercise, we are given that scale factor formula, and in order to find the scale factor, we do the length in the scale drawing over the original. Okay. Describe using percents the difference between a reduction and an enlargement. So let's recall from yesterday. If the scale factor is less than 100%, that means it is a reduction. And if the scale factor is greater than 100%, then it is an enlargement. Remember, reduction means it's getting smaller. Enlargement means that it's getting bigger. Use the two drawings below to complete the chart. Calculate the first row, drawing 1 to 2 only. Okay, so corresponding sides are the sides that are the same. So this corresponds to this, and this side is going to correspond to this side. We are looking at drawing 1 to 2. So drawing 1 for the beginning, it says drawing 1 to 2. So that is, drawing 1 is going to be our original. Okay, so drawing 1 is our original, meaning that's what's going in the denominator. So we're looking at the horizontal first. Ask us to look at the horizontal first. So that is 2.45. And then drawing 2 is in our numerator. That's our scale. So 3.92 is equal to 3.92 divided by 2.45 equals 1.6. Okay, and so it said horizontal, so now we're looking at vertical. And so when we look at the vertical up and down, 1.5 is our original, so that's our denominator. 2.44 is the numerator. So 1.5 is the denominator, and 2.4 is the numerator. .4 divided by 1.5 gives me 1.6. Scale factor as a percent, so we have it as a fraction, we have it as a decimal. We need to change it to a percent, so 1.6 as a decimal, move the decimal 2 places to the right, gives us 160%. And so that is an enlargement. And you notice that the picture was getting bigger. So what do you think is going to happen when we're going from 2 to 1? Okay. Pause the video, discuss with your group. Okay, so you may have said it's going to be a reduction. You may have mentioned that the scale factor is going to be less than 100%. Okay, so 2 to 1. So drawing 2 is now our original going to 1. So everything's just basically going to be opposite. We're just going to flip-flop it because now 3.92 is our denominator and 2.45 is my numerator when I'm looking at horizontal distances. Okay. Make sure you are comparing where you have in your fraction the same pieces, the corresponding sides. So 2.45 divided by 3.92, 0.625. And then 2.4 is our denominator now, and 1.5. equals 1.5 divided by 2.4. 1 numerator divided by the denominator. 0.625. And they should be the same as each other. You shouldn't have two vertical distances unless it's a different piece. And so then we're changing our decimal to a percent. Move that decimal 2 places to the right. Puts us at 62.5%. And so it is a reduction. So our conclusions are correct. It was a reduction, and it also had a scale factor that was less than 100%, which also tells us that it is a reduction. Okay, we are going to be skipping example number 1 and going on to example number 2. A rectangular octagon is an 8-sided polygon with sides that are all equal. All 3 octagons are scale drawings of each other. Okay, so scale drawings meaning they're proportional to each other. Okay. Use the chart and side links to compute each scale factor as a percent. How can we check our answers? Go ahead, let's change this. We're going to change this to this column's going to be on enlargement or reduction. So we're looking at drawing 1 to 2. We're going from drawing 1 to drawing 2. Is that an enlargement or a reduction? So it should be an enlargement. It's getting bigger. So drawing 1 is our original. And then so that's going to be our denominator. So drawing 1 was 10. That's our denominator. Drawing 2, 12. So 12 divided by 10, 1.2. Decimal to a percent, 120%. And so that is an enlargement. It does go along with that. Drawing 1, 2, 3. So going from this one to this one now. And so that is getting smaller, so that's going to be a reduction. Okay, so drawing 1 again is our denominator. And then 3 is our numerator, or drawing 3. So 8 divided by 10, 8 tenths. So 8 tenths, there you go. 8 is in the tenths place. Move the decimal 2 places to the right is considered 80%. Okay, drawing 2 to drawing 1. So now we are going from 2 to 1. So again, that is a reduction. Drawing 2 is our original, which was 12. So that's the denominator. And drawing 1 is our scale. So that is 10. 10 divided by 12 gives me 0.8, and the 3 is repeating on forever. Okay. Moving that decimal 2 places to the right, 1, 2. Okay. So if we're rounding, we can say it's 83%, but we know that 3 is repeating on forever. So more precise, we can say 8.3 with the 3 repeating over forever, 83.3 repeating on forever percent. Or even more precise, 83 and remember, anytime you have a repeating number, we put it over 9. And that can simplify. 3 goes into 3 once, and 3 goes into 9 3 times. So 83 and 1/3%. The next one asks for drawing 2 to 3. So we're going from 2 to 3. So it's a reduction. Our original is 12. and our new was 8. 8 divided by 12 is 0.6, repeating on forever. Move the decimal 2 places to the right. Now remember, this 6 is repeating on forever, so when we fill that spot in, it's another 6. Also, there's still another 6 behind there, so if we're going to round it, that 6 rounds this 6 up, so we can say 67%. We can be more precise, say 66.6 with the bar repeating on forever, or the most precise, or as a fraction with a fraction, so 6. Anytime we have repeating, it goes over 9. 3 will go into 6, and it also goes into 9. So that gives me 66 2/3%. And so that was a reduction. Okay. So 3 to 1. From 3 to 1, so it's an enlargement, it's getting bigger. Okay. So 3 is our original, which was 8. That's our denominator. And then 10 is the new. So 10 divided by 8, 1.25%. Not percent, sorry, 1.25. Change your decimal to a percent. Decimal goes twice to the left, to the right, 125%. And it is an enlargement, it is bigger. And finally, 3 to 2. From 3 to 2, it is getting bigger. So we're going to say it's an enlargement. So original is 8. $12 divided by 8 is equal to 1.5. Move the decimal 2 places to the right. It's equal to 150%. So it is an enlargement. Okay. So to conclude, we're going to skip this. There we go. To conclude, when we have a scale factor that is less than 100%, it's a reduction. When it is greater than 100%, it is an enlargement. And the way that I find it is I do the scale drawing over the original and make sure that they are corresponding sides.